Mean absolute deviation. Mean absolute deviation is what the definition says. It's the average distance of all data values from the mean of the set. So average is mean, distance is absolute, and from the mean, again, is what you need to do. So let's look at what's going on with this. Suppose that you want to find the mean absolute deviation, and the abbreviation for this is MAD. So the first thing you're going to do is you're going to figure out what the mean of your data is. So if I have this data set down here with 60, 56, 58, 60, and 61, I add them together. So the sum of those numbers is 295, and then to find the mean, you divide by as many numbers as there are, and there are 1, 2, 3, 4, 5 of them, and so 295 divided by 5 is the mean. The second thing you do is you find the distance from the mean. And so we're always needing to remember that distance is always positive. That's the absolute part. It's like absolute value. So I take the first number that was in my data set, that was 60, and subtract 59 from it, and I get 1. Second number in my data set was 56, so I subtract 59, and I get 3. Third number was 58. 59 take away 58 is 1. Fourth number was another 60. 60 take away 59, and that's 1. And the last number was 61. 61 take away 59, and that's 2. So the first thing I did was I added all the numbers up, divided them by 5 because that's how many numbers there were. Second thing I did was I subtracted each of the original numbers, the 60, the 56, the 58, the 60, and the 61, from the 59, which was the mean of the data set. Then you average those numbers that you got, those differences. So 1, 3, 4, 1, 1, and 2 make 8. Divide by how many numbers I had. 8 divided by 5, that's 1.6. And that is the mean absolute deviation, or MAD, of the data set. So what's the purpose of the mean absolute deviation? The mean absolute deviation, when you do that, you are looking at the spread of your data, how far apart your numbers go. Other things that show spread are the range and the interquartile range. And if we think back to that original set of data and we look at it, these numbers are all close together, 60, 56, 58, 61, and 60. That's why your mean absolute deviation is just 1.6.